So we're on chapter 6.1, which we're going to briefly talk about the probability distributions. What is probability distribution? Distinguish between discrete and continuous random variables, and using probability distributions to compute probability. Now, just to be clear here, the term PDF in statistics means probability distribution function. Probability distribution function. Okay, not the usual PDF format that we're used to in Adobe, but rather probability distribution function. A probability distribution is a table or a graph that tells all the possible outcomes of a random experiment. And secondly, it tells the probability of each outcome in the experiment. So it gives you a lot of information. Here's an example of a probability distribution table. Rolling a six-sided die. X is 1, 2, 3, 4, 5, and 6, and the probability of rolling a 1 is 1 out of 6. The probability of getting a 2 when you roll the die is 1 out of 6. The probability of getting a 3 is 1 out of 6. The probability of getting 4 is 1 out of 6. And the probability of getting 5 is 1 out of 6. And the probability of getting 6 is 1 out of 6. So this is a very typical example of a probability distribution table. Now, a probability distribution graph gives you an estimate. This is a probability distribution graph of the number of stars. Estimate the probability that a random selected reviewer gave this book a 3-star rating. So right there, 3-star rating, the probability, if you look at it, is approximately 0.1. Okay, right there, 0.1. There are two types of numerical probability. Discrete numerical values that you can list or count. Example, the number of siblings, the number of songs on an MP3 player. And then continuous, cannot be listed or counted because they occur over a range of values. Example, height of basketball players occurs over a range of values. You can't really list them. And the weight of a sandwich varies over a range of values. So you can't really list or count them. Okay, so I want you guys to look at this. Label each of the variables as discrete or continuous. Take a minute, okay, and try this, and then I'm going to come back and see how you did. Which one would be continuous and which one would be discrete. Okay, so let's see how you did. The number of cars owned in a household would be discrete because you can count them. The number of pets owned by a student is discrete because you can count the number of pets. The number of time it takes a worker to commute to a job site is continuous because you can't really list the time. Okay, it varies over a range. It could be 60 minutes one day, 63 minutes another day, 30 minutes another day, and then one day it could be 3 hours. The height of a building in downtown San Francisco is also continuous, or downtown Orlando, or whatever city you choose, because it's a range, it varies. It's not a list of numbers. Two features of a probability distribution. All probability values must be between 0 to 1. And the sum of all the probability values must equal to 1. Now, let's see how we can create a simple probability distribution. Suppose you roll a fair 6-sided die. You win $10 if you roll a 5 or a 6. You lose $5 if you roll a 1. For any odd outcome, you win or lose nothing. Create a table showing the probability distribution for the amount of money you win playing this game. So remember that for 5 or 6, you win $10. There are 3 possible outcomes. You can win $10, lose $5, or win or lose nothing. So here is the X values. You can win 10, lose 5, or nothing happens. The probability of rolling a 5 or 6 and winning $10 is 2 out of 6. Okay, because 5 and 6 each occur one time. The probability of rolling a 1 is 1 out of 6, losing $5. You win or lose nothing by rolling a 3, 2, 3, or 4. The probability is 3 out of 6. So these are our 3 probabilities in the graph form. Now note, all probability values are between 0 and 1, and the sum of all is equal to 1. 1 over 6 plus 3 over 6 plus 2 over 6 is equal to 6 over 6, which is equal to 1. Because you cannot list, the goal here is probability distribution for continuous random variables. Because you cannot list all outcomes for a continuous random variable, we cannot represent the probability distribution using a table. Graphs called probability density curves are used instead. This is a probability density curve showing the probability of wait times before service at a coffee shop, say Starbucks or Dunkin' Donuts. The shaded area represents the probability of waiting between 0 to 2 minutes. The total area under this curve must equal to 1. So let's go ahead and look at some of the problems here. I'm going to do number 1 for you, then you guys can attempt number 2 on your own. It says, determine which of the following variables would be best modeled as continuous or discrete. The number of textbooks authors now sitting at a computer. Textbook authors now sitting at a computer. You can count these numbers, the number of textbook authors. So this is a discrete variable. The number of bald eagles in the country. Again, you can count the number of bald eagles in the country. So this is discrete. The number of people with blood type A in a random sample of 50 people. So you can list all of the blood types in this random sample, A, B, or O, and then you go through and you can actually count how many people have a blood type of A. So that's discrete also. It's the number of light bulbs that burn out in the next week in a room with 20 bulbs, discrete or continuous. wide. So you can count the number of light bulbs that burn out, so discrete. The number of people in a restaurant that has a capacity of 200, so you can actually count the people. So all of these are discrete values. Now, I want you guys to see the difference in the next problem. So take a minute and you look at the problem and see if you can determine which is discrete and which is continuous. The decibel level of a siren, the number of people in line at the box office to purchase theater tickets, the height of a tree, and the number of people in a concert. Take a few minutes, a few seconds, maybe 30 seconds, look over those and see what you think. Random or discrete. Sorry, discrete or continuous. All right, so let's discuss our answers. The decibel level of a siren is definitely continuous because it varies over a range. Okay, you can't really count it. It just varies over a range of different decibels. Some might be higher, some might be lower, depending on if it's an ambulance or a police car or a fire truck. Is the number of people in line at the box office to purchase tickets definitely discrete because you can actually count the number of people. Anytime you can count the number of people, it's discrete. The height of a tree varies over a range of values. Okay? Varies over a range of values. You can't really count. The number of people at a concert, you can count the number at a concert, discrete. Okay? All right, let's move ahead here. Okay, the figure, a magician has shaved off an edge of one side of a six-sided die, and as a result, the die is no longer fair because it keeps landing on that one side a lot. The figure shows the graph of the probability density function One second here. Okay, so they're asking us here to show the table in the format by listing all 6 possible outcomes and their probabilities. So we're looking at the table. You would have an opportunity to blow this up. The probability density, when it's 1, it looks like it's about 0.04 to 6. It's in levels of 2, so this is 0.06. And then all of the ones 2, 3, 4, and 5 are at the same height. I'm going to estimate that to be about 2.2, 0.2, and then 0.24. So each of those would be about 0.22. Okay? Because you're going from 0.2 to 0.24. So the number halfway in between is 0.22. And then at 6, it goes back to between 0.04 and 0.06, which is, between 0.04 and 0.08, which is 0.06. So it's 0.06. Again, that's all they're asking you to do to complete the PDF. The next question is saying toss a fair 10-sided dice. So this one doesn't have any sides on it, shaved off. It's supposedly fair. They didn't rig it. the probability density function in the table form is given below. Make a graph of the PDF for the die. So if it's fair, immediately we will know that all of the numbers are going to go across the same. The probability of getting 1 is 1 out of 10. The probability of getting a 5 is 1 out of 10. The probability of getting a 10 is 1 out of 10. So this will be fair right across the board. You will see that uniform distribution right across at 0.10, right? 1 over 10 is equal to 0.10. So all of them will be across the board at 0.10 because the die is fair, unlike the example we looked at previously where the die was shaved. Eric wants to go skiing tomorrow, but only if there are 4 inches or more of new snow. According to the weather report, any amount of new snow between 2 inches and 7 inches is equally likely. So notice the graph shows between 2 inches and 7 inches. Okay? The probability density curve for a new snow depth is shown. So this is the probability density curve of between 2 and 7. Find the probability that the new snow depth will be 4 inches or more tomorrow. Copy the graph, shade the appropriate area, and calculate its numerical value. So it's saying that tomorrow it will be between 4 or more than 4. So all that's needed here is that we mark a line at 4 and we shade everything to the right of that. In other words, this graph right here, that graph right there, okay? What is the probability that there will be 4 or more inches of new snow? So what is the probability that there will be 4 or more inches of new snow? Now pay attention to this here. So if we consider that between 2 to 7 is 5 inches and 4 to 7 is 3 inches, the probability of 4 or more is equal to 3 over 5. This is equal to 0.6. The rest of the questions you can answer on your own from the notes. I'm just going to do one for you. In statistics, I actually gave you this at the start. Probability distribution function, PDF, also probability density function. That's not listed as one of the answers, but that would also be correct. Okay, that's all I have for you for this chapter. You can answer the other 2 questions from the notes.